Want to support my classroom? As a 7th grade math teacher, I'm always working to give my students the best learning environment possible. So if you'd like to help, you can support our class by donating supplies or purchasing items directly from my Amazon wish list. Every contribution makes a difference and is greatly appreciated by me and my students. All right, so here we have a pretty easy one, just a short one, because I know I've been doing some pretty difficult ones. So we're going to try to find dy dx implicitly, not explicitly, implicitly. So explicitly, I know in previous videos I said we use implicit differentiation when we can't isolate the y. That's true 99% of the time. But this one's pretty easy. This one you could isolate the y, however, it gets a little funky and messy. So what we're going to do is solve it implicitly. So that means taking the derivative of every single term of x and y. So let's go ahead and start. So we're going to have 10x in the first term. That's taking the derivative. Of course, that's being multiplied by dx over dx, but that's equal to 1. So we're just going to write 10x minus 3y squared. That's the derivative of negative y cubed. However, every time you take the derivative of y, you need to multiply by dy dx. Okay? And then, of course, the derivative of 7 is just 0. And now we can solve for dy dx. So let's first subtract the 10x. So we're going to have negative 3y squared dy over dx is equal to negative 10x. And then we can divide by the negative 3y squared. So dy dx is equal to negative 10x over negative 3y squared, which is actually just negative, or dy dx of 10x over the 3y squared. So technically, this is dy dx. Or if you were to solve it explicitly, you'll see that where you have y here is actually whatever y was when you solved here. So if you solved for y, or if you solved for y and then solved explicitly, you would have whatever y was here. I think I had done it up above. I think it was the cube root of, was it negative 7 plus 5x squared, something like that. But if you want to add that y there, if your professor says, oh, you got to add the y back or whatever, add it back. But this is solving it implicitly, and this is our final answer.